Hey, this is Mr. Molo. Going to make a quick video about this investing section to help you pass this quiz. So question 2 was using the rule of 72, t equals 72 divided by r. How long will it take for the principal to double with an annual compound interest rate of 6%? So t stands for time, r stands for rate, and they gave us that rate was 6%. So I just need to type in 72 divided by 6 in my calculator, and it tells me after 12 years that my money will double. 4 is kind of tricky because it has all these things in here, so I'll just kind of explain simple interest versus compound interest, and then we'll go through the right answer. So simple interest is worse for you than compound interest. Simple interest only accrues interest on the money you put in. So if you put $500 into account, after 1 year, it's only putting in interest on that $500. Versus if you had a compound interest account, and let's say it was accrued monthly, so if you had $500 after your first month, then maybe you have like $505 or $510 because of interest. Now you're getting interest on the $505 or the $510, whatever it is, instead of just the original $500. So compound interest is way better for you because it keeps getting interest on your interest. So that's why compound interest has an exponent in its formula, because it keeps getting compounded more and more from the interest. This is why this one's right. Compound interest earns more money than simple interest, like I said, because you're getting money on your interest. Simple interest is only earned on the original amount. Like I said, it's only going to be that $500. And like I said, for the last one, compound interest is earned on the principal amount, so what you start with, plus your interest. All right, here, Alta invests in $345 into a simple interest account that pays at a rate of 9% a year. So using the formula, so we got to figure out how much interest she actually made. So we got $531.30 minus $345. So she made $186.30 in interest. So we know her starting amount, we know her percentage. Now we just have to figure out the year. Lucky for us, this is multiple choice. So I'm just going to plug them in and see which one gets me $186.30. So we got 345 times 9%, so times 0.09, and let's try like 4 years. Well, that's $124, so that's not going to be enough. Let's try 7 years. Well, that's 217, so that's too much. And then the right answer is 6 years. So $180.30 for 6 years. 7. Charlotte just to invest $275 in simple interest for 16 years. That's a long time. The annual interest rate is 8%. Using the formula, how much will Charlotte's investment earn over 16-year period? So she put in $275. Her rate is 8%, and she did it for 16 years. So she gets $352. So that third option there. To save for a car when he turns 18, Pascal deposits $500 yearly into a savings account with an interest rate of 7.5% compounded annually. So that's nice. So we're going to use that formula. So it says he adds $500. So at the end of year 4, he has $2,404.19. But maybe like his parents, or maybe he saves up and adds $500 into his account. So there it is. So now he has $2,904.19. So now we're going to take that account, and then we add the 1, and then the rate they give us is 0.75 or 0.75, and we figure out that he ends up with $3,122.00. So kind of tricky there because he adds 500 every year, so it kind of jumps a little more there. Here, an initial amount of $800 is invested in a compound savings account with an annual interest of 4.5%. Using the formula, what is the balance after 5 years? So we have our $800 to start. Then we have 1 plus the rate, which was 4.5%, so 0.045. And this time they told us it was for 5 years. So I need to do the exponent with a 5. And there it is. I get $996.94. So we round that up to 95 cents. So it looks like it's going to be that last option. Hope that helps.